Do you know of that amazing food item that can make a versatile, high-protein, nutrient-packed food for less than $1 per person or less? While this may sound impossible, this miracle food is none other than eggs, and its low prices are all thanks to math. Hi, I'm Kaylin Klein, and this is my presentation, Mathematical Modeling in Poultry Egg Production. Mathematics can be applied to poultry egg production in many different ways and for many different reasons. One such application is mathematical modeling. Mathematical modeling is used to accurately predict egg production and is important from both a production and a research standpoint. But before we get into mathematical models, we need to understand where they come from. Mathematical models use several factors, as are seen here, to compare egg production to different situations. But they also need to take into consideration how eggs are made and how often eggs are made. As you can see here, eggs are made once every about 25 hours, which causes a lag to be made in between days. This day that's missing an egg separates the groups into clutches. Now, because clutch size is thought to be very heritable, as in passed down from parent to offspring, this is very important from a research standpoint. Now, the more productive hens, such as white leghorns, red sexlings, and black sexlings, tend to have larger clutches with smaller breaks than the less productive hens, these and these, who tend to have smaller clutches with larger lags in between. Now, in order to understand which breeds you're going to get and what kind of chickens that breed will be, they have standards. Now, for instance, one standard is when they start laying. So your more productive breeds will typically start laying around week 20, which is about 4 or 5 months of age, will reach peak production about 2 weeks later, or 2 months later, and stay there for about 2 months, and then decline around 1 year of age, where you need to then either get new laying stock or force your current laying stock to molt and thus renew their laying. Also, different breeds have different egg totals. The leghorn is the highest, with the red sexling and the black sexling being almost tied, except that the black sexling lays slightly less but slightly larger eggs than the red sexling. Also, heritage and dual purpose tend to have about half the clutch size of your more productive leghorns. Now, you can also use graphs, as are seen over there, to represent how even within similar circumstances, different birds will still have their own individual laying patterns. That shows 6 patterns of egg production from an experimental flock with equal breeds, equal food, and equal environmental conditions, and yet there were 6 very different patterns, as well as 25% of the entire experiment which could not be fitted to egg production. But before we ever get into making curves, we have to understand the equations. Now, being that egg production is only just recently becoming an important thing for people to think about, they start off with these 4 nonlinear models, which were used for things such as lactation curves in dairy and egg production of a fruit fly. But with new research has come neural networks. Now, this is a computer program that actually learns and is able to predict outcomes for data that has never been encountered before. This helps farmers minimize losses in new situations they've never seen. Also, for some new research, has created these equations, which are specifically meant for poultry. This one, which is less advanced and just represents production compared to different age. And this one, which is a little bit more advanced and divides the curves into segments. From these equations, you can get many results, as are seen in my cutouts on the bottom here. So, for instance, once you get these results, you need to analyze them in a way that is easy to understand. Tables are slightly more accurate, but they're not as easily apparent as graphs, such as here. But from these, you can understand various different things. This one shows that younger chickens may start out laying a little bit less, but will lay more overall than older chickens who lay more steadily the entire time. The information presented here shows that brown-shelled strains lay more, but also eat more than white-shelled strains. But before you can conclude your experiment, there's one last final step, determining model accuracy. Model accuracy is measured with correlation coefficient, which is from 0 or 0% to 1 or 100%. And this equation over here had 96% correlation, or 0.96 correlation, which says that it's almost at the limit of how accurate real-world scenarios can be to a static equation. Once you have determined your factors, your equations, and determined the model accuracy to be stable, you can use this information for future research, study, and as a tool for today to help you boost the happiness, productivity, and health of your flocks. Thank you. Are there any questions?